me guys if you guys don't aren't getting something. Okay, so this says on which intervals is the graph of f concave up? So if you want to know where the graph is concaving up, you have to know what f double prime is. Once you find f double prime, make a sign line graph with it. So kind of like what we did over here with this guy, with this function f, we made a sign line graph. Here's function f. We made a sign line graph for f double prime. And to do that, we got to take the derivative twice, and then we have to find the possible inflection points, and then we have to do tester points. So that's our roadmap. That's what we're going to do. Let's do it. Okay, whoops. Come back. There we go. Oh, man. Cool, same thing. Okay, so here we go. I'm going to first find f prime. Now, because we have this thing on the denominator, we're going to have to use the quotient rule. So I'm going to stick that negative to the 81 just to make sure I don't lose it. Now, the derivative of 81, negative 81 is a constant, so that means the derivative of it will be 0. So 0 times the denominator. Now, I normally wouldn't write this, but I'm going to be thorough, so you guys hopefully are tracking with me. And then we're going to go minus. Now I'm going to take the derivative of the denominator. Now the denominator I'm going to rewrite to say x plus 5 raised to the 1/3 power. So if I took the derivative of that, it would be 1/3 times x plus 5. And I would get negative 2 over 3. Oh yeah, and then the derivative on the inside is just 1, so I didn't need to do the chain rule, the full-on chain rule. But anyways, 1/3 times x plus 5 raised to negative 2/3. And then we have times negative 81. The denominator, I'm going to rewrite this denominator with the 1/3 power, gets raised to the second power, says the derivative. All right, now let's see if any cool things might happen. This is gone because it's multiplying times 0. This is not going to be negative anymore because I'm going to make the negative 81 multiplied to it, so it's gone. So now I have 81 over 3, and I have x plus 5 raised to negative 2/3 all over x plus 5 raised to the 2/3 also, right? Because we have to go 1/3 times 2, and whenever you multiply a fraction times a regular number, you put 1 underneath it to remind yourself, I multiply straight across. Oh, dang. Do you guys see what just happened here? Oh, dang. Now, if I do a little bit of manipulation, I will have an 81, and the 3 will go on the bottom because you can multiply the top by 3 and the bottom by 3. That's how you get rid of the 3, the fraction inside the fraction. And then you can also multiply the top by x plus 5 raised to the 2/3. That would add these together and give you 0, and that would go away. And then I'd have to multiply the bottom by x plus 5 raised to the 2/3. So the bottom, you're going to have x plus 5 raised to the 4 over 3. This is f prime. Oh, dang. I'm going to need some space here. So there's our f prime, but we need f double prime. So I'm going to have to take the derivative yet again. So let's write out what the f double prime is going to be. So we got, again, a constant on top. This time I'm not going to write it. I'm not going to write the first part. I'm just going to write 0 minus 81 times the derivative of the denominator. Now, the derivative of the denominator, okay, we got a little bit more fun here. We have 3x plus 5 raised to the 4 over 3. We take the derivative of that. We would drop the 4 over 3, multiply it times the 3, we get 4. Then x plus 5 raised to the 1/3. Because you have to take away 1 from this, I would take away 3 over 3, so we get 1/3 there. And then the derivative of the inside part is just going to be 1, so I don't have to do the chain rule here because the derivative of the inside is just 1. So I'm multiplying the 81 times 4 times x plus 5 raised to the 1/3 power. And then on the denominator, I have to square it, so I get 3 squared, well, here, I'll write it like this. 3 times x plus 5 raised to the 4 over 3, and I got to square it. All right, a little bit of simplification. All right, here we go. What is 81 times 4? I don't know. That's 4. Okay, so 324, negative 324, x plus 5 raised to the 1/3. Oh man, this is getting really dirty, guys. And then on the bottom, let's see, we're going to get 9 and then x plus 5 raised to the 8/3. Ew, look at that f double prime. That's disgusting. Now, when you do the power right here, don't forget you have to do it to both of these. You have to raise this to the second power and raise this to the second power. And when you do that, you have to multiply the power times 2. Or not this to the second power, raise this to the second power. But anyways, I'm going to show you guys something that's going to, make you a lot happier. Okay, now what we're supposed to do next is we're supposed to find the inflection points. And so in order to find the inflection points to this, we're just going to take the negative 32, negative 324, sorry, x plus 5, that's raised to the third power, and being divided by this. And we're going to set this equal to 0. See, this is when this gets awesome, because the denominator doesn't matter now. Because you can multiply both sides by the denominator, it would go away, and then you would just have to figure out the top equaling 0. What does that give you? So we have negative 324 x plus 5 raised to the 1/3. Wait, why is it 1/3? It should be 8/3. No, oh, that's the numerator. Forgot. Okay, and then divide both sides by negative 324, so that would be gone. And then we just have this. We just have x plus 5 raised to the 1/3 equals 0. What does x have to be to make this equal 0? Now, you could do inverse operations, from Algebra 1. We could raise this side to, what would it have to be? The second power? No, the third power to get rid of the 1/3, and raise that to the third power. So then you have x plus 5 equals 0. Then you get x equals 5, negative 5. But you probably could have done that without doing that part. And so, wow, we did all that to do this finally last part. Okay, here's our sign line graph for f double prime. Here is negative 5. We got to do a tester point before it and after it. We'll do 0 to see if we have concaving up or down for each interval. Okay, so I'll check that out. We have to choose one answer. So it's going to be one of these. It's either going to be less than negative 5 or greater than negative 5. X is less than negative 5 or greater than negative 5 to give us concaving up. So we want to know which one of these is positive. All right, and only one of them can be positive. I kind of cheated. I looked at the answers. Okay, so let's just plug in 0 because that one's easy. Yeah, that's a good idea, Mr. Patey. Where do we plug it in? We plug it into f double prime. So when we plug 0 into f double prime, what do we get? Now we plug 0 in right there. We plug 0 in right there. What will we get? So we have negative 324. Wow, this is really involved. Like, I didn't realize this was going to take so long. And on the bottom, we have 9 times 5 raised to the 8/3. Okay, now stop for a moment and just think for a sec. The top, the numerator, we're going to get a negative for sure, right? Because we have a negative number multiplying to whatever that's going to give us. I don't care what it's going to give us. I know it's going to be positive, so positive times negative is going to be a negative. And the denominator is going to be positive. So what is that going to be? What is that number going to be? If it's negative divided by a positive, what's it going to be? It's going to be negative. So that's negative, which means this one has to be positive. We want to know where we're concaving up. We're concaving up when we're less than negative 5. So this is going to be our answer. Let's do it to it.